I'm using Claude Shannon's definition of a code, which is that a code is a set of rules governing a communication system. That is what a code is. And that is what the genetic code is.
But that's the problem. That's like saying the legal system is a set of code by which we have to obey ourselves in society. Therefore, DNA is a code, and it's a legal code. No, it's not. These are completely different meanings of the word. I think you're equivocating on this grossly, a matter of fact, because Claude Shannon was not a biologist. He's talking about information system, and I don't think he ever argued DNA was a code. Matter of fact, again, Crick himself argued it's not a code, and he's a biologist. He's the one that discovered the structure of DNA.
Yeah, Crick doesn't understand communication systems. That's why he didn't know that. But Richard Dawkins was a computer programmer.
Biology.
Hold on, Steve.
Richard Dawkins was a computer programmer and a biologist, and so Richard Dawkins understood perfectly well that the genetic code is a code. That's why he wrote an entire chapter.
I don't think that's what he said.
In his book.
I think you're reading it incorrectly. It's digital format.
You can read it.
Again,
there's a PDF online. It's free.
I have read it. But again, I think that you're seeing the word code and you're not taking heuristically. You're not taking it as an analogy a lot of times. Again, the only thing that's actually a code in cryptography would be that A, T, C, and G letters. That's what a code means. And I think you're just throwing everything, information, sender, receiver. By the way, even with a sender and receiver, when you do coding, we create the sender and receiver to understand something. So even if computer sends to a computer, it took an intelligence to make that computer understand the other computer in that regard. Yeah. You're saying you used the analogy that a ribosome is an agent recently, right? On Facebook, which I didn't understand because a ribosome is not an agent. It can be a receiver for information, but it cannot be an agent the way Claude Shannon was classifying as an agent, because he used the term agent, meaning agency, meaning an intelligence or human being, from sender to receiver, two people communicating.
That's
that was
from
his
wrong.
paper. That's from his paper.
No. From his paper, he says it could be a person or a thing can be the receiver.
The transmitter you're incorrect. The transmitter could be a thing. The transmitter could be a thing. The agent.
Want me to pull up the paper? I can pull up the paper.
Yes, I've read it.
All right. Let me pull it up for you.
My goodness. All right. Things are getting heated. Oh my goodness. Is DNA a code? Is it not a code? What definition of code are we using to decide if DNA is a code?
Okay, on page 2, you didn't have to read very far. He says that the destination is the person or thing for whom the message is intended.
Okay, in this particular case, the destination, right? The destination is like a receiving, not the agent, but like a computer, right? That's the destination. But who created the computer? You're assuming that the destination. Look what it says for send and receiver. I read what you're reading. Read what it says for the agent.
Let me read the receiver. Let's read the receiver. The receiver ordinarily performs the inverse operation of that done by the transmitter, reconstructing the message from the signal.
Right. Exactly. But the agents that he's talking about are the people, right? You don't say that a computer is an agent. It has no agency.
Why does
it have to be a person?
Because when you use the word agent, that implies agency, the ability to think on your own, right? A computer doesn't do that. We have to establish the format by which a computer receives something.
Could you be imbuing that meaning onto his paper, though? Like, could you be imbuing that meaning onto it based on your understanding?
I know. I've asked people about this. I've actually asked.
Argument from authority.
But yes, Kyle. Yeah. Kyle's on top.
I will. I say that because this is heavy stuff. But you have to have an intent here. You have to have an agency, right? If I want to communicate something to Shannon, there's an intentionality there for me to say I need her to understand my message, right? There's nothing between the ribosome and the DNA that has that intentionality.
So you're saying in order for there to be a code, there needs to be intent from the sender.
In the strictest sense of the word, I think so, yes.
Okay. Well, now I don't want to get into an argument of teleology here, but what we find when we study the origin of life is that as soon as you have descent with modification acted upon by natural selection, nature selects for things that are good at surviving and reproducing. And when you look at them do their thing, it looks like they're doing it on purpose. It looks like they have purpose. It looks like they have intent. Things can evolve. I mean, you and I are evolved creatures, so our intents are actually evolved intents. much of them, the base intentions that we have. The gene is the gene is holding information that is to be sent out to the ribosome, so the ribosome can decode it into a protein. And the whole purpose of this is survival and reproduction. So,
okay. Well, the problem I have with that is you're trying to relate, like you said, teleonomics with teleology, right? The teleology would be something an agency that designs something. But teleonomics doesn't require
we're
that.
now off topic.
Well, yeah, but this is interesting. The nature can design something, right? But that doesn't mean it has to have an actual agency. There's no agency in teleonomics. That's what Darwin was brilliant in pointing out, that natural selection can do this without intentionality, without agency. That's why Darwin's was so unique for the time, because everybody at the time thought it was theologically only. They only thought theology was the only way this could operate, this could work. And he said, no, we have something that has the appearance of agency, but it's not agency. Yes. It's not intentionality, right? And so when you're talking about this, the things that you're looking at, you're making the same mistake I think the intelligent design advocates are making, because there is no intentionality there. There's no intent.
No. What I'm saying is that it's not true intention. There's no being on top of it telling things that want stuff to happen. Right. The intent, if you want to call it intent, evolved because these are the sorts of things that evolution does. It produces these sorts of things. So the fact that you think that it needs to be a person that is communicating code is just wrong. I mean, it says right here, person or thing, so. Literally in black and white on the page, right here.
I understand that, but as I've tried to explain, by the way, I did say or thing. I read it before, so I knew what it said. A thing. That's why I asked the experts. Or thing is the fact that you have a computer, which is the thing, designed by a higher agency. Right? We designed that thing. So it still requires some kind of intentionality behind it. You're just looking at it and going, it doesn't have to be a human. That's true, but who designed the computer?
I just explained to you. Sorry. I just explained to you that bacteria can communicate.
Has agency.
Steve,
do you think that
he just started talking?
I never said that a ribosome has agency today. Like, I don't know if
but
I said that
prior and
oh my God,
okay.
Dave.
Prior said that, and so I was kind of confused.
So
we're gonna think that.
All right, so let's talk about the agency that a ribosome has then, if that's what you want to talk about. So the ribosome itself, it can only do one thing. Within a specific environment, it can only do one thing. It can only do what it's evolved to do, which is to take a messenger RNA and convert that into a protein. That's what it can do. But across generations, you could say it has agency because mutations can slightly tweak it, and natural selection will then select for versions that are better at surviving and reproducing. The differences that exist in the genetic code, you talked about this earlier. What is one of your arguments to say that the genetic code is not really a genetic code is that there's different versions of the genetic code in different organisms. That's true. There's also different versions of binary code. We use ASCII code. That's the American Standard Code. But there's other versions of binary code. These are just different. The rules are different. A code, again, is the set of rules that govern a communication system. That's what we're talking about when we talk about code and computer science.
Yeah, that's the equivocation problem. And by the way, agency by definition requires a consciousness. Okay, you have to have a consciousness of agency.
Steve, let him. Okay, go ahead, John, and then I will throw it to Steve. Finish your thought, John, and then I'll throw it to Steve again.
Okay, let's not use agency because you don't like that word. Let's say degrees of freedom. The only degrees of freedom that a ribosome has are those that accumulate across generations through mutation. The genetic code can change across generations through mutation, and it's mutations in tRNA will cause a change in the genetic code. That's how new dialects evolve. New versions of the genetic code evolve through mutations in transfer RNA. That's how they evolve. And if anyone wants a more in-depth explanation of how tRNA works and the ribosome, the whole translation system, I did a video yesterday actually on the Stated Casually channel, and I've got a video on the Stated Clearly channel called "What is DNA and How Does It Work?" But
you're just trying to explain the redundancy and the degeneracy of the code on itself, right? You're trying to explain why different species make code for a different amino acid, right?
Yeah,
And
so
why
our
different-
mitochondria, for example.
And why you might have three letters code for a different amino acid. Because
Right. The rules,
again, third base
the rules that
that's
govern
through evolution.
Yeah,
The rules
that govern the communication system will evolve slightly. Yes.
Rules as a code is only one of the most loosest definitions, because again, we have rules in law.
Yeah.
We have a codification of law. That's not how we use the terminology when it comes to DNA.
It's the definition used by Claude Shannon in communication theory. So if you don't like it, that's fine. That's what people are talking about when they talk about code.
Like you said, like an instruction set is a set of code, right? How to do something. But this is not how any biologist that I've talked to, and I've talked to 3 biologists with PhDs so far, none of them use it this way. So, I mean, if Claude
none of them
Shannon
understand communication theory. But Richard Dawkins does, which is why he wrote an entire chapter on it.
All right.
I think they kind of do.
Everybody finish your thoughts. Steve, go ahead.
Okay. Go ahead,
I'm good. I'm done.
All right, Steve.
You're good? Okay.
You're done? Okay.
I have a question.
Right,
Kyle, do you have a
Question
super chat or anything? Because if not, I have a question.
No, I was gonna let Steve finish up his point. I didn't know he was finished with his thought. So go ahead, Shannon.
Okay. So here's my question. I think this is kind of an all-important question. So essentially, Steve, what you're saying is just definitionally, by the stringent or strict definition, because colloquially, I think you would agree that a lot of people would say that the genetic code is a code. That's why it's called a code. So colloquially, based on a general understanding, a lot of people would, and John would probably argue that even more than that, he would expound upon that more people would, even on a finite level, would call it a code, because you take information, that information is transmitted and deciphered and ends up in something that is predictable based on how the letter sequences appear. So like if the letter sequences appear in a certain way, like CTAG, you will see something, a protein, be produced consistently because it's translated into that protein consistently. So like that, to me, that sounds like a code, and I'm no biologist. You essentially, it seems like a semantic argument to my mind, to my sad little non-biologist mind, that it's not a code. It's essentially what you would call a cipher. So it's just a minor shift in definitional terms. You would probably say it's not minor, but for somebody like me, from the outside looking in, that seems like a minor semantic shift in definitional terms that might be moderately frustrating.
I'm using it. I'm gleaning what you're saying. I groke.
Okay.
I'm using the most strictest forms of terms here, but I have to ask you, when you say the genetic code is a code, what do you mean by genetic code?
I mean the chart of codon.
No, what does she?
The genetic code is these.
No, hang on. She asked the question, so I want to know what she means by you, because she said if you ask anybody if the genetic code is a code. Well, when you say that, what do you mean by the genetic code? But what is the genetic code?
I'm not talking about
He's saying it's the codon chart.
So when the RNA goes through the ribosome, the RNA, the letter sequence on the RNA is being read by the ribosome, and the ribosome is turning that into a protein. And it's turning it into a type of protein consistently based on the letter sequence that it's reading on the RNA. Does that make sense? I may be
it does.
misconstruing that.
I think I personally,
I'm not
this is my summation. No, this is my summation. The genetic code, when I think of the genetic code, I think of the letters A, T, G, and C. Those are a code. Those are secondary symbols representing a primary symbol. No problem.
When did they stop being a code?
When you talk about information. When you're just talking about the information that's flowing from one point to another point, that's not a code. That's information in the system. That's not transportable. You can't take that information and convert it to binary. Codes have to be transportable. You have to be able to convert it from one form to another. You can't do that in this particular case.
So
I can convert the ATs,
put it
Gs,
into a computer,
symbols.
and a computer could make a protein? Just because there's only one thing that can decipher the code and turn it into a protein.
How do you convert, if I say DNA there's code in DNA, how do I convert that into Braille?
Right.
The only thing that's the Braille's going to show is